Bismillahirrahmanirrahim. In this very short video, I'll try to explain some of the basics that you have to keep in mind while choosing an oscilloscope. Okay, the fundamental thing that an oscilloscope displays is the voltage amplitude, and it is related to the time axis. So the horizontal axis is the time axis, and the vertical axis is the amplitude axis or voltage axis. And some of the measurements that can be done, one is the voltage with respect to time. Other, from the same, we can calculate the frequency and phase. We can also calculate DC and AC components. We can calculate rise time and fall times. And we can also do some high-level analysis, that is the mathematical analysis, spectral analysis, etc. Now, I'm sure you must have seen oscilloscopes, at least the analog oscilloscope. This is the old type. Analog oscilloscope has tube in it, and that this is like this here. It's a long one. It has a CRO tube inside, and the signal were deflected through plates and then projected on the phosphorescent screen. Now this is fading away. Digital oscilloscope is taking place, so it is very thin, as you can see. And the basic principle here is that this oscilloscope measures the signal, analog signal, converts it into digital signal through analog to digital converter, stores it in memory, and displays on the screen. And as we mentioned that it takes sample from the analog signal. So if this is the analog signal, the digital oscilloscope takes sample. For example, this is one sample, then this is second, third, fourth, and convert these samples into digital values and then store it into memory. So you can use either 8 bits for storing or 256 bits for level. 8 bits means actually that you can have 256 levels of the signal. Okay, a very important element that comes in the specification is the bandwidth. The bandwidth is like a road which can take many people or less people, etc. So in this case, the definition is this specification indicates the frequency range that the oscilloscope can accurately measure. And this will just see in the next slide what does this mean. Okay, so let's see, we have a 50 megahertz square wave signal which looks like this, and we want to see this signal on various oscilloscopes of different bandwidth. So first of all, we are taking an oscilloscope which has a bandwidth of 60 megahertz. Now the signal is 50 megahertz. Oscilloscope bandwidth is slightly more, but this oscilloscope is not reproducing the signal correctly. So there is, you can see distortion in the whole signal. Okay, now we go for a bigger one, so 100 megahertz. So 100 megahertz is slightly better than the previous one. You can see this is flattening here and flattening here. So we go to another one. This is 350 megahertz, and this looks better now, except for some kinks here and there. So we further increase it to 500 megahertz, and the 500 megahertz oscilloscope will give a much better presentation of the input signal. So from here we can conclude that what is the maximum frequency of the signal that you want to measure. You have to keep that in mind, and if you multiply that with 5 times, 4 to 5 times, a rule of thumb, that the oscilloscope should have bandwidth 4 to 5 times higher than the maximum frequency you wish to measure. So we, in the previous slide, we saw that for 50 mega, when we went to about 7 times, then the signal became much better, and 10 times was very much better. Then we also come across what is known as rise time and fall time. Now, rise time is the time it takes from signal from 0 level to 100%. Actually, it is from 10% to 90% level. So this time gap is called the rise time, and similarly the fall time. And this obviously is for more important for digital signals. We want it to be more accurate. And keeping in view the rise time and fall time, we can also determine the bandwidth. So the bandwidth of a signal, bandwidth multiplied by rise time, should be equal to 0.35. This is also again a rule of thumb. And so from here, the bandwidth of the signal can be 0.35 divided by rise time, if we know that. Then the term called sampling method or sampling. What is sampling? Now let's say this is an analog signal, and we want to represent it in the form of a digital signal. So we take samples. We're taking one sample here, then the other sample here, then third sample here. So this is called sampling. And the faster the sampling is, the better will be the reproduction of the signal. And here also the thumb rule of 5 times is applicable. Use a sample rate of at least 5 times your circuit's highest frequency. And generally 10 giga samples per second or 5 giga samples per second is common in the digital oscilloscopes. Next we come to the memory of the oscilloscope. Now the purpose of memory is to store the digitized signal. So if this was the analog signal that has been digitized, or we have taken samples, and this is the value of the sample, let's say, then this will be stored in the bit form, and so we need lots of memory, and the bigger the memory, the bigger will be, or the faster will be the performance of the oscilloscope. And finally, we have a term called waveform capture rate. Now, while sample rate indicates how frequently the oscilloscope samples the input signal of a waveform, the waveform capture rate refers to how quickly an oscilloscope acquires waveform. Now, remember that the signal or the wave is changing, so how quickly or how many waves per second this can capture, that capability is called the waveform capture. And oscilloscopes with higher capture rate can easily show the changes or quick changes like transients, like jitters, glitches, etc. in the reproduced signal. And here is an example, just whatever we have talked. This is the bandwidth. I'm comparing two oscilloscopes. Then it is showing that it has 4 channels, 4 analog channels. Then the real-time sample rate is given here. Maximum memory is given here. Waveform capture rate is given here. And digital channels. Now this oscilloscope has digital channels, but this one does not have. And we'll see what is digital channel means, what does it do. Okay, here is an oscilloscope. This is called mixed signal oscilloscope. Now this has both the analog signal capturing capability. So this analog input comes with these 2 probes, and it also has the digital input signal. Now digital, as you know, in the digital electronics or in the modern day communication, everything is digitized. So it has either a 0 volt or 5 volt level. So this oscilloscope can show both digital and analog, as it has been shown here. This is the analog signal and this is the digital signal. Now previously for viewing digital signals we used to use digital signal analyzers. Now this oscilloscope has made that redundant, and now both types of signal can be presented on the oscilloscope. And finally, a little bit about the probes. The probes here also, the probes should be 5 times. Probes bandwidth should be 5 times the signal bandwidth. So this is an analog probe, and this is also called passive probe. That means it does not have the capability of amplifying, rather it has the capability of reducing, so we can attenuate by 10 or by 100. This is most rugged and most economical probe. The active probe has amplifier in it, and this is generally used for high input impedance circuits or high frequency circuits. So I hope this gives you an idea as to about the oscilloscopes, and when you are selecting an oscilloscope, if you keep these points in mind, you will have a better bargain. Thank you.